And here we go again. We've talked about parallel lines, we've talked about perpendicular lines. Now what we need to do is take two line segments and decide whether they're parallel or perpendicular. Parallel, they have the same slope. Perpendicular, they are negative reciprocal. So the question that I have here talks about line ST passes through the 2 points, S and T, and line UV. Are these two lines parallel, perpendicular, or neither? So justify your answer. Well, first thing, it wants us to verify to see which they are. So if we take S, -2 and 7, and T, 2, -5. Just going to write them like that so that we can do a quick check as to what the slope is. Now, remember slopes rise over run, so it's change in Y. So we're going from 7 to -5. So that's a difference of -12. And we're going from -2 to +2, so that's +4. So my slope equals -12 over 4, which equals -3. That was for ST. Now you take the point UV, and we have -2 and 3, and we have 7 and 6. And what is the slope for that? So do the same thing. UV. We're going from 3 to 6, which is +3. And we're going from -2 to +7, so that's +9. So the slope in this case is equal to 3 over 9, which simplifies to 1/3. Now, they're not the same, so they're not parallel. Are they perpendicular? Well, the quick check for that, if you can't tell from looking at it, is if the slopes are negative reciprocals, they will have a product of -1. So we can check that real quick. -3 slope ST times 1/3 slope UV equals -3 over 3, which equals -1. So these lines are perpendicular. How can we verify that graphically? If we put the two lines on the graph, we should see ST, -2 and 7. -2, 7, right there. 2 and -5, 2, -5, right there. Nice quick bad line by me. That's ST. And we should have -2 and 3. -2, 3, and 7 and 6. 7, 6. And that would be UV. Pretty darn close. It's a bad drawing, but it's close to showing you that they are perpendicular.